So thank you everyone for joining. This is the third in a series of webinars that 𝘂𝘂𝗱𝗶𝘁 and Tech Data have been doing to highlight advanced security features of the 𝗔𝘂𝗱𝗶𝘁𝗄 Vault product. And very glad to be joined by Sam Sainty from the Tech Data Center of Expertise supporting IBM technology. You could go to the next slide, please, Narayana. I'll just introduce the team. Narayana is the technical leader of 𝘂𝘂𝗱𝗶𝘁𝗏, and I'm in charge of sales and consulting services delivery for our clients. And 𝘂𝘂𝗱𝗶𝘁 is a IBM partner that is specializing in cybersecurity use cases, particularly around the 𝘊𝘂𝗱𝗄𝗏 family of products, as well as IBM's data security and identity products, as well as, of course, also including Red Hat Ansible automation tools. So if you could go to the next slide. As I said, this is the third in a series of webinars we've been doing highlighting advanced security use cases for the 𝗔𝘂𝗱𝗄𝗏 Vault product. And I think it's particularly interesting at this point that as we are focusing on compliance-related use cases, that some of the more complex features of the Vault product are starting to come to light in this webinar. And we're actually also going to touch on some of the use cases that support agentic AI, but that's the next session. So you'll have to wait till the next session to get the full detail on that. But I think this will be a pretty interesting webinar because there's going to be a number of kind of themes that are going to come out in this. If you could go to the next slide. So looking at the regulatory landscape, I think there are several themes that are coming out. I mean, most people would be aware of the focus now that ASIC and APRA and the Australian Signals Directorate have been putting on improving the security of artificial intelligence solutions. And that's one theme. But, you know, we were already looking at the proliferation of non-human or machine identities in the enterprise environment. I think the ratio here that's quoted of perhaps typically there being 50 non-human or machine identities for every human identity in the enterprise environment now has probably already been exceeded. I've seen quotes as high as 100 or 110 to 1. And when you consider all the range of different non-human identities that's now being expanded to include AI agents as well, that number's just going to get bigger. And starting to appear on the horizon this year also is the need to consider the renewal or rejuvenation of enterprise cryptographic environments with the Australian Signals Directorate's guidance on post-quantum cryptography and the requirement in the Australian Government Information Security Manual to have a transition plan in place by the end of 2026 to move to post-quantum cryptography. It all comes back actually to the themes which I think we've been working on for 10 years or more on the right-hand side, which is around, you know, the need to automate the provisioning of infrastructure and applications to deal with this cycle of repair, rotate and repave your applications and infrastructure rapidly. And again, coming back to AI again, you know, the threat that we've seen emerge in the last few months from frontier AI models like Mythos, really compressing the window available to defense teams to defend against threats. So that's where I say I think there's a whole bunch of themes that are starting to come out this week in this webinar and we will try and touch on them, as many of them as possible, but we will also have a follow-up session next time to talk specifically about agentic AI. Next slide, please. So I'm going to dwell particularly on two different sort of sets of regulatory requirements here, one being the Australian Government Information Security Manual, because, you know, of all the regulatory standards in Australia, it has the most specific technical guidance to deal with cryptographic risks. And so that is kind of a cross-cutting set of guidance which needs to be considered, but also going to look at it particularly through the lens of the Australian Prudential Regulatory Authority standards for financial service providers, because they also kind of draw out some of the key themes and features that 𝗥𝗲𝗄𝗡 can provide to support compliance use cases. So themes around operational risk management, management of identities, and compliance, observability, and reporting. Next slide, please. So I particularly want to draw upon a very insightful blog post which Martin Milthorpe from 𝘊𝘂𝗶𝘁𝗄𝗏 published, I think, late last year, highlighting the capability that the 𝗥𝗲𝗄𝗏 suite of products has to support compliance obligations in Australia. And those are particularly around management of short-lived secrets, certificate lifecycle management, operational visibility and compliance, and business continuity requirements. But I want to add to that because I think what 𝘗𝘂𝑓𝘆 is seeing, you know, is, as I said earlier, that cryptographic agility is now becoming a consideration in the enterprise environments. And of course, the dealing with non-human or machine identities and agentic AI is now a big theme supported by this product too. So what we're going to try and do in this demo this afternoon is highlight some specific features which are shown on this chart around capabilities that Vault has to support those requirements. And now I'm going to hand over to Narayana.
Thanks, Dave. So as you can see, this slide is kind of our attempt to map various capabilities against requirements that are mandated in different regulatory guidance. Like, for example, there are exact numbers of which section talks about dynamic DB credentials and what various organizations that have to follow that regulation need to do. And so we tried to correlate between the capabilities of 𝗥𝗲𝗄𝗏 Vault against those specific requirements from regulations. Again, so with respect to 𝗥𝗲𝗄𝗏 Vault, if you are not super familiar with it, so I think it is trying to solve around three different aspects. The first one is like, what are the kinds of secrets or important keys or certificates, or it could be your database credentials, API keys, AI API keys, or cloud-related secrets, your encryption keys. So you have a wide variety of keys. Some could be simple static key value pairs. Some could be your server certificates or internal certificates that are required to secure your internal infrastructure. But overall, you have different kinds of secrets, and then you have different kinds of identities. One could be human identities. The other are machine identities, like an AI agent or a service account. It's a machine identity. And we have seen earlier from one of the slides, the ratio is 50:1. So what we are trying to enforce is, how do we translate all our secrets that are required to operate our infrastructure into a storage which is extremely restricted and protected. And there is an option to rotate it, and you can version it, and you can do a lot of other things. And you want to make sure who has access to this. So that comes through the policy framework. So a policy is where you are saying these identities can access these secrets. And then, so that's how you define the policy. And that's one way to keep the authorization under control. And the other aspect is like, how do I define identities? There are quite a few different authentication mechanisms, starting from simple tokens to username, password, or you can use one of the existing identity providers. So I'll be showing you it in the demo. And finally, how do we make sure the whole purpose of this exercise is to identify any insider threats or any hacker attacking, right? So the whole idea of security. And so how do we ensure that is through the audit capability. So if we are auditing, if you have all the logs and if you are passing it to your SOC for further analysis, so it's easy to detect why did I see so many authentication failures to a particular secret and from a particular identity, things like that. So you can do all the rules and analysis in your thing when you have a very good audit capability. I might quickly show you a few use cases around HashiCorp Vault, and then I'll hand it over to Sam, who's gonna show us some of his dashboards around the audit logs. Right, so this is an example environment that I could just created for the purpose of the demo. It's based on community edition. So whatever you're seeing here is part of a free community edition, but the enterprise edition will have a lot more capabilities. And so there are multiple different kinds of secret engines that might be available on an enterprise edition that are not available on an community edition. So be aware of that. So like I said, the whole essence of this is like the secrets. So what's a secret engine? Secret engine, think of it like it's the type of secrets you want to store. What are the different types of secrets, right? So they can be related to they might be a simple key value pair. So you can create any number of key value engines. So it's a secrets engine that essentially stores keys and values. It could be your API key. And then I can retrieve it programmatically. Whatever I'm showing in the UI, everything you can do it through the CLI or you can do it through API calls. Typically in your DevOps environment, you'll be using API calls to retrieve or to write or to rotate these secrets. So it can be your Kubernetes related secrets. It could be your LDAP related ones, or it could be, you can run your whole PKI system in a vault. So you can connect to an external PKI CA provider, or you can have your own internal CA. You can create self-signed certificates. You can rotate them from time to time. And you can also store your SSH keys and certificates. So you can store your TOTP. The transit is interesting. So if you have applications which require encryption, we have something called encryption as a service. How it works is, let's say you have plain text, you have an encryption key, you want to send that plain text to this engine, it will encrypt it, give you back your ciphertext, and then you can store it in your database. So it's between the application and the database. You can call this encryption as a service and provide those functionalities. And you can also connect to all these clouds. They all have their own secrets manager. So you can have an multi-cloud secret manager kind of a scenario where you want to have rotation or you want to control everything. You can do that.
So by the
And
way,
then,
Narayana, I think that transit capability could be a very useful capability for cryptographic agility, right? That maybe, you know, you're trying to remediate legacy cryptographic vulnerabilities in your applications, So maybe, adopting Vault here to be able to provide quantum safe encryption as opposed to the legacy encryption services might be a useful capability that Vault can provide.
Yes. So we can create, like Stephen has mentioned, we can create different secret engines, and transit secret engine would be useful to store your encryption keys. So in this example, you can see I have created a few secret engines. In the PKI one, you can see you can configure your PKI. So you can, if you already have an existing CA that you would like to use and you have the private key as well, you can import it and start using it to publish certificates. And if you want to just use it for an internal purpose, and if you're happy with self-signed CA certificates, you can do that as well. And you can create a CSR for signing purposes. And like I said, the key value is a simple way to create your secrets. These are key value pairs. You can see I have a Cloud API key. So all I'm doing is I created the key here. This is a secret, and you have the key and the value. And I can create a new version of the secret. So tomorrow, if I want to use a different API key, I can just create any number of versions. And there is metadata associated with this as well. Like you can add more metadata to explain what this key is all about. And so essentially everything is stored in the form of folders and files. So if you want to call this programmatically, this is the API path. So what you do is you request for this key from this location. And when we want to create a particular policy around this secrets, again, we will create based on the path. We say anything in this path, I want to create a policy around whether I can read, write, or whatever I can do. So I'll show you that as well. So if I go back to the main menu, I have access control. This is where I can create ACL policies. In this example, I have given the path to that API key, and I said this policy, I can only do read, write, read, create, update, and delete. So I can edit the policy, I can add more things to this. That's quite easy to write as well. And now I will apply this policy to a particular user or a particular group of users. So how do I do that is by creating. So again, there are multiple authentication methods. So you can see we support app role. This is mainly for service accounts, JOT, Kubernetes based one, OIDC or TLS certificates based. This is the most simple one with an username and password. And you can also use one of the cloud-based IAM systems, or you can use Okta or Radius. And you can also enforce MFA if you like. So there are multiple options available for you to configure an MFA flow. So in my example, I have one of the authentication methods is user password. So I have created an user called Narayana, and Narayana has got a password. And you can see I have applied this Claude policy as at the user level. So this user has Claude policy as one of the policies for the token. So can access anything that's governed by this policy. So if I go to Narayana, which I have it here. So now I'm logged in as Narayana, and then you can see I can see the key value here. That's because I have defined that policy that Narayana can do a few things here, but it will still ask me what is the location of the secret, and then I'll be able to see the secret there. Any questions so far?
I have one question. That is like how HashiCorp Vault is different from AWS Secret Manager.
Yeah, there is a differentiation I can share you after the call. exactly differences, but this is more like not every client is on AWS, right? So it's a multi-cloud architecture, and let's say you have multiple clouds, you have on-prem as well as AWS, and you want to have some common policy across your whole infrastructure. Or if you have the
Got it.
same users accessing both, then you will need something that can orchestrate, right, across the different infrastructures.
Sure. And second question.
Also, I think there's quite a few additional functionality differences between the two. I believe that AWS can't do certificate authority or encryption as a service. I think there's a few other things that I can't quite remember right now, but functionality-wise, there's just a larger feature set for doing more diverse things when it comes to Vault and its ability to secure stuff.
Sure. Thank you, sir. And the second question is, we have seen one of the screenshot which was talking about like credential lifetime is 2 hours, and after that it is about to change, right? So over here we're talking about non-human identities. So once the credential changes, will it be a push operation from 𝘔𝗂𝗱𝗶 side to notify the application like it has changed, to pull it, or how does the push or pull operation work between 𝘔𝗂𝗱𝗶 and the business application?
I think Sam's earlier demo, he had certificates, right? So they were rotating from time to time.
So, so it depends on the application. And if you're talking about enforcing the policy from, so for example, if I have a credential stored in Vault, and then I'm securely accessing that credential using some Vault key that's generated from it, then it's as simple as adding a policy. But if you're referring to updating the source username and password and then needing it updated in Vault, it just depends on the environment. So something in like, if you're using OpenShift and you're updating the username and password, that gets stored in a secret. That secret is synced with Vault. It does it automatically. If you have completely separate systems and no way to sync any of them, but then you would need to update the Vault to make sure that the username and password are the same for the source. But when it comes to key rotation, what I do is I post the key on Vault. I have a policy that automatically requires it to reset every 20 seconds and can only accept from particular IP addresses, and when the key expires, it has I think it was a 4-second gap where it can request a new key, and if it doesn't have the old key and request the new key in that 4-second gap, it is then locked out. But I'll jump into that when we get into the drone demo, but on a little bit of a higher level.
I think it will be based on the architecture, I think, how you're designing it.
Yeah,
Sure.
but that's the flexibility of Vault, realistically. It's intended to be able to be a secrets and a secret manager for everything, not just for the compatible things, if that makes sense. So it depends on the approach you want to take and the applications you want to integrate.
Sure. And does it the code feature for on-demand rotation? Example, if we can make REST API call to inform 𝘔𝗂𝗱𝗶 like we want to change the password. So do we have that kind of feature too?
Yeah, absolutely. So you would have a policy manager, which would have either like 1 or 2, or sometimes we even have 5 API keys that you all need to do at the same time before you can make a change. It depends on how secure you want it to be again. And that policy manager could then update the username and password through an encrypted exchange back and forth. So for example, you would have let's say you are running an old Peppermint or Salesforce system, and someone submits a ticket in there with a new credential update for a database. And instead of having to go in there and update the database and then update the Vault, you could have a third-party agent that's able to scrape the information from the ticket, update the Vault using the secured credentials that you've given it access to from Vault, which can be on a key rotation, or it can be on credentials, or it can be on an extended big key. And that will exchange the information back and forth using Vault to then update Vault. Is that?
Thank you, sir. That's helpful. Thank you, Narayana.
Yeah, like I said, encryption as a service. So here you can see you can encrypt data. Let's say I have test, and then it's using that key I created earlier as an encryption key, and it will give the ciphertext. And then I can decrypt it back, it will give me the base 44 version. So if I go back and check the base 44 version, it's test right. So that's how the encryption works. What I showed you in the UI, like typically if there is an application, they can call 𝗔𝘂𝗶𝘁𝗶𝘆 to do the encryption and decryption and creation of the encryption key. And then there is also rewrap. Like let's say tomorrow you want to rotate the encryption key itself, then it provides a way to just give the ciphertext, and without having to do anything, it will decrypt and re-encrypt with the new key, which makes life easier. So you don't have to do that. It's all done by 𝗔𝘂𝗱𝗶 itself. And then you can verify that you can generate digest, HMAC digest, and you can also verify that the digest is not tampered with. And it does allow versioning of it as well. Like I can say rotate key here. When I say I can rotate key from the UI, which means you can also rotate it from the API. So again, with database as well, you can connect to a wide variety of databases. And this is probably you are seeing a limited set here because of the community edition. But if you look at the enterprise edition, there are many more databases. You might want to have dynamic database credentials and which are short-lived. And the other areas are the resilience and recovery. This is the HADR. If you want like business continuity, you might need an HADR operation there. So that's again a feature of enterprise, as you can see here. And you can seal the vault. That's another feature. Like let's say something happened and you don't want anyone to access a vault, you can seal the vault. Yeah, over to you, Sam.
All right, so let's go ahead and share the screen. I'm on limited display today. So I'll come back over here because this is where we left off last time. And I just want to show this where we were basically. So last time we talked about this, we talked about the importance of key rotation, and in our fictitious company, which is a drone company in Sydney, we have 15 drones that go and deliver, pick up and then deliver packages. And since we're exposing these drones, which have API access to be able to pick up, reset, and maintain our jobs, we want to make sure that those drones are secure. And if we have any kind of interruption, or if we have an outage, or if we have potentially a malicious actor, we want to make sure that if they get the hardware, then our APIs are secure, our data is secure, and we won't have an issue with any kind of exfiltration of information. So whenever last time, key rotation is really important. It's another layer of security. If you're talking about your Swiss cheese method, every single layer you put in front of it gives you a larger chance to fully complete a wall that is impenetrable. So the more layers, the better. Key rotation is a huge and a very important and a very impressive layer of that whole process. And that's sort of what this demo is based on. So let's just quickly do a little recap, and then we'll jump straight in. So we're going to crash one drone, and we'll come back over here, and we should see in a moment we have a drone has been revoked access. So the 20-second key rotation has happened right in that time. And now, if someone were to recover this drone, extract the key, it'd be completely irrelevant. So we can go ahead and reset that. Actually, we'll leave it like this for now. We'd send a technician out. They would issue the drone a new key and put it back in the system. And we could continue along our way without fear of those keys being used maliciously. Now, what does that look like on the back end? We're going to get into this in a little bit. But there's something else that's really important here that we haven't touched on a lot, but is critical to the whole thing being valid and secure, and that's auditing. So every interaction that happens with Vault is automatically audited, as long as you connect your storage and set up the system to an audit log. And this audit log doesn't store any of the secure information. Anything that is considered secure information is encrypted with a salted M265 hash. So it's completely unreadable, but we can understand exactly when something happened, why it happened, and where it happened, which is really critical when it comes to understanding when you have attack surface, if something is being attacked, is something is potentially vulnerable, is something happening below the scenes, which one is great being denied by Vault because we have proper security practices, but two, maybe we want to be a little proactive about trying to secure it, and three, audit and compliance requires that you do have logging. So in our system here, we're using our OpenShift environment, and inside of our OpenShift environment, we have our drone system running with all of our fictitious drones flying around. We have our Vault system, and we also have our 𝘂𝘂𝗱𝗶𝘁cie system here. So we're using 𝘂𝘂𝗱𝗶𝘁cie as the log connector for Vault, and 𝘂𝘂𝗱𝗶𝘁cie is a log collector. That's what it does best. So it's a database that is able to connect into a bunch of different applications, scrape those logs, collect them, and unify them. Now, something that's really cool about Vault is you don't have to pick one log provider. You can actually hook up as many as you'd like as a redundant way to make sure that, for example, if something happens, something gets compromised, even if the log platform gets compromised, we can still be sure that we have some sort of redundancy to make sure that our system, that is our source of truth, is truly our source of truth. So it's really critical amongst all of this. And I actually want to thank 𝘂𝘪𝘵𝘪𝘵 for going into all the policies and how we're doing it here, because I was going to jump into that, but it's saved us a lot of time, so we won't go through that. But we have the same policy process here, where we have particular agents that have policies. Those policies allow those agents to do particular things to help this whole thing rotate without giving any permissions outside what is required for those agents to do their job. So let's get into the auditing, because auditing is one of those big things. It's kind of scary. It doesn't look very pretty because it's just a big log, but for the sake of the demo, I wanted to make it look pretty, and I wanted to make it a little usable and see what we could get out of building a dashboard using Grafana hooked up to our elk logging to show the activity on our drone infrastructure. Now, this is something that I've sort of just put together to try and make as much utilization out of the drone demo as possible. Oh, it seems like my drone crash one hasn't ticked over. Let me just refresh that. Maybe it's an issue with my syntax. So all of the logs are all being fed through Elk, and Elk is able to connect to Grafana, and we're using Grafana as a way to visualize this information. We can have our inputs and outputs, our rediscoveries, and this is something I like to put on our Grafana sheet because I think it's actually a valuable key piece of information. It's denials based on IP over the last 60 seconds. Now, it's normal for our drones to lose denial because over that 4-second exchange. But what we want to do is make sure that we're not having a external source or a huge collection of external sources making requests and getting denied. That means that we are likely having someone attack. Or we should at least investigate to make sure nothing's going wrong with our networking. We don't have some sort of loop somewhere, or someone hasn't written a rogue Python application that's doing something nonsense. Now, moving down further, we can see our data flow and where all our requests are going and how that is split up, and of course, where our drones, how much of the drones are utilizing the platform and their existing statuses without errors. Now, coming down to the audit log, this is where it gets really important. It comes back around to knowing everything, seeing everything, and being able to back up everything. So as you can see here, every single one of the audit requests here is a drone either requesting or refreshing a token. And any of the sensitive information here, like I mentioned before, was the 𝘂𝘂𝗱𝗏 encryption with a random seed, salt, meaning that it's completely unreadable for the sensitive information, but we have exactly when, why, and how, and where from it has come for that response. So that's what the key concept of running your audit platform is to have a single point of truth, that truth to be 100% valid, and potentially, if you can, validate with a second source. And that's something that all that Vault fully supports and allows you to do straight out of the box, even on the non-commercial version. But moving on to doing the multi-cloud management stuff, of course, you're going to need the enterprise. Now, do we have any questions? Is there anything else you'd like me to get into when it comes to understanding the logs here and understanding how auditing is, one, required, and two, a kind of another layer of security that you can implement that doesn't require anything other than Vault? So, any questions?
I have an example. So, example, if we talk about agentic AI agents, so some of the flows include consent from the human actors at critical stages in a business workflow. So the logs capture that kind of mapping, like agent is working for which owner, which will be a human actor, or consent who has consent to that.
I can answer that, Sam, if you want.
Yeah, please.
I think that's part of the next session that we are going to do on agentic AI security. But recently, Vault and Verify, they have introduced an integration based on SPI FFE, which is a common framework. So they are going to create like an agentic registry. So each agent, AI agent, will have its own identity. So that will help with exactly the problem you're mentioning, like what's its identity, which AI agent is accessing this secret or this data, and then who's the corresponding human who it's delegating its permissions from.
Can I just add to that too? I think the Vault radar function is also useful in this respect because it can help you to identify non-human identities that are acting in the environment as well.
Absolutely.
On top of that, is there any kind of feature which can help in detecting the fraud kind of stuff in those transactions? Because it will be a huge data to process when application is in production. So, are there any AI capabilities in the product which can?
You're looking more along the lines of like probably IBM Guardian security and stuff like this. That's doing more. Yeah. Okay, sorry, I'll let Narayana go on.
It requires correlation, like with the financial transaction and the additional, like for example, Trustier or any of those other products which are very specific to financial. So if you can correlate back to what it has found, and then you can come back to the audit log and see, well, that was a suspicious transaction based on the amount and the recipient and whatnot, and the anomalies. Then you can add additional context around it. What happened during that time? Who was the user? Was it an agent or a bot? What was it actually doing? So that additional context it can give, it can't do it by itself, right? Because it doesn't have that level of detail. So it has to correlate with other ones.
Got it.
Yeah. Sam, is that all?
Yeah, that was mostly what I wanted to cover. I was going to go through some of the Vault architecture policies and engines but you covered all that perfectly, better than I could. So I think that if there's no other questions, I'm happy to say that I'm done here. If you would like, I actually make these projects fully available on GitHub, so you can deploy them yourself. You can run your own test environments. You can even start messing around with Vault yourself and see what you can use it in to make sure that it's the right fit for you, because it's flexible, it'll fit. So I'm going to put that in the chat. If you feel free to play around with the code, and if you would like any assistance in the future, just let the 𝘔𝘂𝗱𝗏 team know. We'll be in touch.
Sure.
Thanks, Sam.
No worries.
Tino, did you have another question for Sam?
All good, Stefan. Right now.
Great.
I do have questions from the previous session. I will still filter down the list and send it across for like queries.
Sure.
Okay. Well, I think that about wraps it up. This is our last slide. I just wanted to say, as I said at the beginning, 𝘂𝘓 is not just a reseller for the 𝘔𝘂𝗱𝗏 and IBM products, but we also provide professional services to support organizations that are adopting these tools. So, for example, in relation to some of the things that we've shown you today, we can help you with architectural reviews or planning. One of the things that we're very actively doing for clients at the moment is helping them with those regulatory requirements around preparing transition plans for post-quantum cryptography. But we're also very familiar with the AI use cases as well. And the next webinar in a few weeks' time will be specifically highlighting some of the challenges around securing AI. So please come back for the next one too.
Will do.
So thanks very much for your
time.
time. I think we've
Thank you,
finished
team.
early
Very-
today.
Yeah,
Thank you,
very
guys.
good. Very
Archie,
interesting demo. Look forward. No, I don't have any questions. More just thank you for your time. Very interesting demo. I'll be
Thanks, Archie.
touching base with Tinu, and yeah, we'll come back with any other follow-up questions.
Awesome.
Right.
Have a good day. Cheers.
Thank
Bye.
you.
See you guys.
Bye.
Bye.
Bye.